How does an algorithm go from a university research lab to a multi-billion-dollar empire? From legal AI startups hitting $5.6 billion valuations to Anthropic potentially reaching $900 billion in just weeks. Welcome to the AI boom. Let's dive into the journey from lab to ledger.
If you've glanced at the tech news lately, honestly, it can feel like pure chaos, right? One day, a new AI model is casually passing the bar exam, and the next, some startup you've literally never heard of is valued at the GDP of a small country. And then boom, massive server outages are dominating the headlines. It is a lot to take in, but today in this explainer, we're going to connect the dots. We're tracing the direct path from the quiet, super methodical research happening in academic labs straight to the trillion-dollar commercial tech market. We're looking at the whole lab-to-ledger pipeline to actually make sense of this AI boom, using the latest updates straight from MIT CSAIL and the front pages of TechCrunch.
Okay, so here's our roadmap for today's explainer. First, we'll look at the research foundation. Second, the massive valuation boom. Third, the hardware scramble. And finally, friction in the machine. Let's just dive right in.
Section 1. The Research Foundation. MIT CSAIL's groundbreaking work.
You know, every explosive market valuation and every viral consumer app we see in the headlines, it all starts right here in the academic lab. MIT's Computer Science and Artificial Intelligence Laboratory, or CSAIL, is basically a perfect window into the true cutting edge of AI. Way away from all the hype and the marketing buzzwords, these researchers are tackling the most fundamental, complex problems that are actually holding AI back. Just look at this first piece of research. They are literally teaching AI models to say, "I'm not sure." And guys, this is massive. If you use AI, you know all about hallucinations, right? That's when a model super confidently gives you a completely wrong answer. It's a huge barrier for companies wanting to adopt AI. So instead of just throwing more data at the problem and hoping for the best, MIT is taking a really careful, methodical approach. They're engineering models to recognize their own limitations and actually express uncertainty. It's a brilliant reminder that true intelligence isn't just about knowing the answer, it's about knowing when you don't know the answer.
And this cautious approach is built directly into the physical architecture of AI too. MIT has also developed a new technique that makes AI models leaner and significantly faster while they're still in the learning phase. Right now, training a major AI model requires just an astronomical amount of energy, time, and raw computing power. It's wild. By finding ways to make the learning process itself more efficient, researchers are tackling one of the absolute biggest bottlenecks in the entire industry. They're essentially trying to make sure the future of AI doesn't require draining the entire global power grid just to teach a model how to read.
And this brilliantly illustrates just how broad this academic frontier really is. MIT CSIL isn't just looking at one specific thing. They're diving deep into recursive language models, which is basically AI that can loop back and verify its own thoughts. They're publishing new research that completely overturns our previous assumptions about how AI might actually overtake human workers. And they're even building the world's largest collection of Olympiad-level math problems, which they're open sourcing to push AI reasoning to its absolute limits. The sheer volume of foundational work happening here is just staggering.
But here is where we hit a really fascinating crossroads, because MIT's focus is cautious and foundational, right? Building leaner models, teaching AI uncertainty. But meanwhile, the commercial focus? It is aggressive, unhesitating, and completely driven by multi-billion-dollar fundraisers and this frantic race to build AI agents that can replace traditional apps altogether. It's like the lab wants to get it right, but the market wants to get it now.
Which brings us to Section 2, the massive valuation boom. Tax race for capital. When we pivot from the quiet academic labs of MIT to the financial headlines over at TechCrunch, the atmosphere completely flips. The tech world is currently locked in an unprecedented, historic race for capital. Investors are absolutely terrified of missing out on the foundational layer of the next internet, and the numbers we're seeing, they're almost hard to wrap your head around. Just let this massive number sink in for a second. $900 billion. According to TechCrunch sources, Anthropic, one of the top AI research companies, could be raising a new $50 billion funding round. That would drive their total valuation to $900 billion. And this could happen in a matter of weeks. We're talking about nearly $1 trillion in value for one company at the center of the generative AI space. This isn't just regular growth, it is a financial arms race, playing out in real time.
Now, what's really interesting about this is that the boom isn't just happening with those broad general-purpose AI models like Anthropic or OpenAI. Niche, highly specialized AI is exploding right alongside them. Take the legal AI startup Legora, for example. They recently hit a $5.6 billion valuation. They are locked in this heated battle with their rival Harvey to totally dominate the legal tech space. And it just goes to show that investors truly believe AI is going to fundamentally rewire specific, high-value industries like law, and they are more than willing to pay a massive premium to back the winner.
And the crazy thing is, this capital is even flowing into purely conceptual, theoretical frontiers. DeepMind's David Silver just raised $1.1 billion to build an AI that learns entirely without human data. Think about that for a second. Up until now, AI has been trained on the massive troves of data that we humans have created. But this new venture, it's backed by over $1 billion just to figure out how AI can generate its own knowledge. The sheer scale of the financial bets being placed on the future of this tech is just mind-blowing.
And that leads us to Section 3, the hardware scramble, the physical cost of AI.
Here's the thing, though. All of this conceptual software and all of these billions of dollars, they rely on something very tangible. Remember, the cloud is just someone else's computer, and AI algorithms require a massive physical footprint of real-world computing power. So the software boom we just talked about is triggering an absolute earthquake in the hardware supply chain. This quote from TechCrunch really says it all. Apple was surprised by AI-driven demand for Macs. You know a market shift is profound when it catches a logistics master like Apple entirely off guard. Consumers and developers are out there upgrading their local hardware specifically to handle AI workloads. So the AI boom isn't just living in giant data centers. It is directly translating into physical hardware sales right at the consumer level.
And this creates the ultimate friction point. On one hand, we've got record-breaking hardware sales. Apple is hitting incredible financial milestones, even as Tim Cook prepares to step down. But on the other hand, looming over the entire industry like a dark cloud is a severe, critical chip shortage. You can't just magically print more silicon, right? So this contrast between the infinite ambition of software valuations and the very finite physical constraints of our global chip infrastructure, that is the defining tension of the tech world right now.
Which brings us to our final section, Section 4, Friction in the Machine, Growing Pains and Fallout.
Moving this fast, scaling this incredibly quickly from academic lab algorithms to trillion-dollar markets inevitably causes the entire system to crack under the pressure. When you inject billions of dollars in unprecedented demand into a technology that is honestly still being actively figured out, you're going to get severe growing pains and real-world fallout. So the crucial point here is that basic security and infrastructure are really struggling to keep pace with the speed of tech development. Looking at the latest TechCrunch reports, the vulnerabilities are widespread. We've got hackers actively exploiting a bug in cPanel, which is a control board used by millions of websites. Major Ubuntu operating services were hit by outages after a coordinated DDoS attack, where they were essentially flooded with fake traffic. And a bug in a dental practice software recently exposed patients' private medical records. As our reliance on digital infrastructure deepens with this huge AI push, the surface area for cyber attacks and catastrophic bugs is expanding way faster than we can patch it.
And beyond the technical bugs, the corporate friction is reaching a boiling point too. We are seeing incredibly intense legal clashes that will absolutely define the market's future. For instance, Elon Musk recently testified that his company, xAI, trained its Grok model on OpenAI's models. Meanwhile, OpenAI is restricting access to a service called Cyber, following a very public dispute with Anthropic over usage limits. And zooming out to the broader tech ecosystem, the massive legal fight over Apple's App Store fees is now heading straight to the Supreme Court. The giants of the industry are actively going to war over data, access, and distribution rights.
We have covered a massive amount of ground today. We started in the quiet halls of MIT CSAIL, where researchers are carefully teaching AI to admit when it's unsure. We tracked how that foundational science fuels a market where companies like Anthropic are rocketing toward trillion-dollar valuations. We saw how this software boom is violently colliding with the physical reality of hardware shortages, and finally, how the resulting friction is causing serious security vulnerabilities and legal warfare across the whole industry. Which leaves us with one vital, provocative question to consider. As AI continues its aggressive scale from lab algorithms to a dominant market force, can our physical infrastructure and security truly keep up? Think about that as you watch the headlines this week. Thank you so much for joining me for this explainer, and I'll catch you next time.